This car is moving really fast, but it may not necessarily be accelerating. For a car to be accelerating, it is essential that its velocity changes with time. Because in physics, acceleration is defined as the rate of change of velocity. And when velocity changes, it may increase or decrease. If velocity increases with time, the acceleration is said to be positive. If velocity decreases with time, the acceleration is said to be negative. And if the velocity remains constant, the body is said to have zero acceleration. Now, acceleration is a vector quantity. That means it has both magnitude and direction. So what is its direction? Acceleration always takes the direction in which velocity increases. When velocity increases towards the right, the acceleration is towards the right. When velocity decreases towards the right, the acceleration is towards the left. Because acceleration is the rate of change of velocity, acceleration would be equal to change in velocity upon time, which means that acceleration is equal to final velocity minus initial velocity upon time. So if a is the acceleration, v is the final velocity, and u is the initial velocity, and t is the time, the acceleration a would be equal to v minus u upon t. And since change in velocity is measured in meters per second and time is measured in second, the SI unit of acceleration would be meters per second, which is equal to meters per second square. Now let's understand the concept of acceleration with an example. A car starts from rest and achieves a velocity of 20 meters per second in 5 seconds. What is its acceleration? We use the formula a equals to v minus u upon t and replace the values, and we get the acceleration as 4 meters per second square. What this would mean is that the velocity of the car increases by 4 meters per second every second. However, in this case, 4 meters per second square is the average acceleration because we only know the initial velocity and the final velocity. We do not know the velocities in between. However, if the velocity of the car increases by 4 meters per second every second, then at 0 seconds the velocity would be 0. After a second, the instantaneous velocity would be 4 meters per second. After another second, the instantaneous velocity would increase to 8 meters per second, and this would continue till at 5 seconds the instantaneous velocity is 20 meters per second. So here we see that the velocity increases at a uniform rate, and this is an example of uniform acceleration. So in uniform positive acceleration, the velocity increases at a uniform rate. Similarly, in uniform negative acceleration, the velocity decreases at a uniform rate. And this is an example of non-uniform or variable acceleration. And now, the summary of this video. Acceleration is defined as the rate of change of velocity. Acceleration is positive if velocity increases and is negative if velocity decreases. A body moving with uniform velocity has zero acceleration. The direction in which velocity increases is the direction of acceleration. In uniform acceleration, velocity changes at a constant rate, and in non-uniform acceleration, that does not happen. So that's all in this video. In the next video, we will discuss equations of motion.